Cengage Learning is a leading provider of innovative teaching, learning, and research solutions for the academic, professional, and library markets worldwide.
There is a bug, out with the old, in with the new. Sergey is Director of Product Management for Test and Performance Tool at Smart Bear Software, the one that Betty was telling us about. And in his more than 15 years in the software industry, Sergey has held positions in every part of the software lifecycle, from QA to engineering and engineering management, professional services, pre-sales, and product management, where he's not. And his passion in software, as well as in life, is a holy grail of achieving high quality with a least effort. Well, that's a holy grail indeed. And Sergey has presented on subjects of the software quality lifecycle, automated testing, and application security at ST Expo, Embedded System Conference, RTCC, Better Software Conference, and ICCT, and written for Dr. Dobbs, EC. So now I'm going to pass the mic to him.
I was actually amazed that I've lived in New England for 15 years, and most of my work experience is here. And I'm a little embarrassed that I haven't come to this meeting before. But now I'm aware and here, and as I said, very glad to be here. One thing that I realized while driving in was that, well, it's already 6, it's past work, and normally I would be in a different place. But now I come to this auditorium and I see quite an impressive crowd, so I'm very grateful for you to actually come and listen to the talk. I'm very pleased to see you. So what we will discuss today is the, well, a little bit of Agile history, but more of Agile future. I decided to call it Out with the Old, In with the New. Is Agile really revolutionary? Not because I'm particularly interested in revolutions, but because most of us, well, some of us here, I guess, already went through the transformation and adopted some of the practices, and some are probably looking at it. Smart Bear is a pretty diverse company in terms of the constituent parts. We have a lot of products that came from different companies, and those development groups use different practices. We're not fully agile. We have some more agile, some, I'd say, relatively calcified in terms of how they do things. And so we're looking at ways to get us more agile as a company. And so some of the considerations that I put on the slides are very relevant for us. And I'm working with a few groups where in the same business unit, actually, one group is Agile and some others aren't. So whether it is revolutionary or not actually has a lot of impact on what's happening with the adoption, because that determines the threshold. If it's really revolutionary, you basically need to apply a lot of efforts to get a lot of people into a new state. Whereas if it's not, the transition is a lot smoother. So in terms of the agenda, rather than saying what I'm going to talk about, I decided to ask why we actually come here. And the first thing is learn something. It certainly applied to me as I went through the prep. I learned quite a bit. I'm hoping that I can share that with you here. Socialize our questions. As practitioners, as managers, as product owners, we inevitably run into problems. We try to solve them. We have questions that we can answer through books, through talking to colleagues, through forums. But sometimes we just need to talk to somebody like us. And I hope that this presentation would be a good forum for everybody to share the questions as they come. Same with sharing experiences. I certainly would like to hear, in response to what I'm going to talk about, what your experiences have been with these transitions, with specific practices or specific methodologies. so that we can all sort of enjoy the greater knowledge. And now, of course, that is the showpiece. I'm not here for that specifically, but I guess that is part of it. We wanted to show SmartBear to this group, and David, thank you so much for presenting our case, because you saved me from doing that. Now that said, at the end of the presentation, as an appendix, because there are slides on the website, there are a couple that say what SmartBear is and what we do. So in case you are interested, you can go and look there. So this is how this talk started, because Ron and I were talking about what to present on. And just about that time, I came across this article on powers of two. And the way I came across this article, it was posted on our social media site inside SmartBear by a member of one of the old-fashioned teams, I would call them. And there was a lot of excitement around test-driven development. And the first thing I thought was, it's great because it's a known Agile practice, and we need to promote more of that. But at the same time, I realized that I ran into test-driven development probably 15 years ago at least. And so when an article starts by asking what's the return on investment on TDD, which is there in the first paragraph, the question is, are we sure of what we're doing? And is it really common knowledge what the methodologies bring to the table? Now, my first experience with TDD was oddly completely outside of Agile. And it was when I joined the company in 1998, and I was given a 2-week task to refactor a fairly large pile of code. But fortunately, the code had a good number of test cases. So as I was working with that code, I realized that there is a lot of help in actually having tests. So the tests were created for me by somebody, and they were immensely helpful in getting me to where I wanted to be, because as kind of a newbie in the company, I was a little nervous in terms of what was going to come out of it. So thinking back then, the company that I was with certainly wasn't Agile, there wasn't anything near, but the methodology clearly worked. And since I clearly recall what that was like, and all the useful elements that test-driven development brought, given all the questions in the article, I asked myself whether test-driven development is just a technique that can be applied to more or less any development methodology, which was my thought, or is it a fundamental principle that is sort of raised to a new level with Agile approach. And more importantly, how this discussion might relate to the Agile change or transformation in general, because as people who have written or tested software for a substantial number of years, does it mean that when Agile comes, we have to kind of throw everything out the window, or we can reuse a lot of what we already know? And this is a diagram of, I hope that most of you know what TDD is, of course. But this was a very cute diagram in the case study article that was referenced in that Power of Two blog post, which went through a number of software groups. I think one was with Microsoft and 4 with IBM, or vice versa, and then analyzed the benefits of TDD. But I thought that was a excellent diagram, and it emphasized something very important in relation to my previous experience, because I really was using existing tests and I didn't change them much. I didn't run the tests with every line of code change. Of course, they weren't that well-defined task requirements other than take this pile of code and make it better. I was actually refactoring it from C to C++. So with the approach that TDD has in Agile, which is much more finely applied than at the system level, it has the same validity at the system level. The benefits are pretty clear. It's not necessarily the practice itself, it's the practice in the context of Agile. The benefits are certainly worth noting because, granted, it was a business level blog. Faster time to market came as the first point. One very notable detail, and I will talk a bit more about defects and quality, etc., was a factor of 2 to a factor of 10. Yes?
I wondered, when I see test-driven development, what is the counterpart or the alternative or versus? And I'm thinking, is it requirements-driven development that is being compared to?
Do you mean as far as the experiment at hand, so to speak?
Yeah, like test-driven development. I mean, it's something saying, okay, you do that instead of doing something we've normally done before, and try to think the thing we've normally done, sounds like you develop to the requirements. So would test-driven development be the alternate to requirements-driven development?
So let me first repeat the question. I'm not sure whether it was captured on tape. The question was, when we say test-driven development, what do we really compare it to? Whether it's requirement-driven development or something else. There were actually similar-sized projects in that study. So I guess every one of us could compare it to something else. But in the study itself, it was, well, the basics, of course, is that people will write unit tests before writing their code. And it's a fairly specific rule. And the first difference was that there weren't unit tests involved in the alternative projects. We can call it requirements-driven development, assuming that there are requirements, right? Because it's not always obvious what the requirements are, whether they're valid, and what they actually mean. Sometimes it's a whiteboard conversation, you just start recording. The point of the study was a specific implementation of unit tests and attendant, as you can see in further statistics, increase in code base, some increase in effort, and the overall results to the delivery of the project. Going back to this question, as I was pondering it, there's a lot that says that Agile is revolution. It started with a manifesto, and granted, my socialist past, as I'm from Russia, that reminded me of the manifesto of the Communist Party that drove a lot of revolution. So the very word actually associates for me with a revolution. But in practical terms, it was billed as a radical departure from ways of the past, which sounds a little scary because you do it all or nothing will work. And that is the theme that is fairly consistent in Scrum workshops, because what we hear is that the methodology is a whole, and doing it piece by piece won't necessarily bring measurable benefits. And then there are, of course, theories about Agile, starting with the theory of constraints that was applied to that, etc. But at the same time, since not all the companies grant to enter the field, there was a lot of morphing. And as in our case, with Smart Bear, we have a mix of methodologies inside the company. And more significantly, it's certainly a Japanese way that they don't do anything in the rush mode. They try to do very incremental improvements. Kanban emphasized the notion of incremental transition to Agile. My first experience with Agile, which was extreme programming, was pointed to the fact that it actually is revolutionary. I was still at that company that I gave the first example of. And in 1999, in a magazine review, I read about the book on XP, and I picked up the book. And it was a fairly progressive company by account. It was an innovative engineering company. We had a lot of automation there. We had very quality-sensitive people. We had a bit of code review, which are all good quality practices, but XP felt dramatically different. We couldn't implement it. There was a lot of change that we perceived to be done, but it was very fascinating because that's the first time we heard about peer programming, for example. So we actually didn't do it. For a methodology, because XP then clearly presented itself as a methodology. One thing to think about a change is what does a methodology consist of? And it's not necessarily uniform. There are principles, in other words, why we do things the way we do according to extreme programming or Scrum or Waterfall. Then there are practices, which is what we're doing. And then there are infrastructure and automation and tools, which basically says how we're doing them. And different parts of a methodology have sort of different degree of shock and different longevity. And so from the point of view of analyzing Agile, it makes sense to look at principles and compare them to what the previous methodology stood for. Practices and tools. And of course there are people who are basically responsible for putting all of that in practice. And when you think about anything in that way, there are probably a lot more interesting analogies and discontinuities that pop up. Let me give you an example using the extreme programming principles. And so I'm going to talk a little bit about principles, and I'm going to look at practices that are associated with those, and look at some of these practices and tools in the context of transitioning from sort of X minus one, whether it was waterfall, unstructured development, to Agile. So among this list, which is kind of an abstraction of Ken Beck's book, one can clearly see that the principles are very different from requirements-based waterfall software development. No one will call that lightweight. All right, so there's, if properly implemented, we think about year or 2-year projects with heavy engineering effort, fat test plans, etc. And XP certainly emphasized an approach which is quite different. One team. We all know that with large waterfall projects, there are the people who write requirements, and those are not the people who write code. And then there are different people who maintain the builds, if there are. And then there may be one or more testing teams, etc. So it's definitely not one team. Evolutionary design. that's also pretty clear that it's a major difference from the past, because if anything, the design wasn't adaptive. It was set, and then you sort of progressed down the path. Short development cycles and incremental planning also look like radically different principles. They certainly support the adaptive nature of extreme programming and other agile approaches, and they represent a serious departure from the previous practices. So, in principles, extreme programming, as basically our example showed from the past, where we looked at it and said, that probably wouldn't work. That is a major jump. The practices were also different. Pair programming, radical concept. After 10 years after, I'm still not quite comfortable with that, but I know people who do that successfully. User stories are a concept that existed before, and I'll talk about that a little later, but it was definitely emphasized from the user point of view, because the whole concept was focused on customer and customer acceptance, whereas requirements could have been what the user wants to see, or the requirements could be how the system should behave, which are very different things. So then we have weekly and quarterly cycles, very short iterations, introduction of continuous integration, etc. So the practices of XP, for the most part, also appear to be very different. What does this tell us is that XP is a large enough jump for many organizations to attempt. Now, Scrum. Scrum, interestingly enough, came not from software engineering people, but from manufacturing, and it originated a little earlier than extreme programming. And the lack of some specificity in terms of how Scrum teams are organized leaves a little, or sometimes a lot more room for A, interpretation for convenience, and B, for reusing some of the practices that existed before. Characteristically, it also emphasizes the one-team approach, which seems to be kind of the underlying structure of all Agile. And incidentally, that's what most of the companies who adopt Agile struggle with, because they're so used to the separation of responsibilities. Certainly the case with our own experience. Then the introduction of product owner and Scrum Master, and managing schedules in short but complete chunks. So these are all principles on which you can hang various practices to support them. And while not necessarily related to software engineering, the practices nonetheless made sense because they focused on organizations of the teams. Sprints, stand-ups, managing of the backlog, and retrospective meetings. Does that look different from waterfall? Very much so. Wouldn't spend a lot of time on this slide. This is the summary of the Agile Manifesto without reproducing the longer sentences that they were on the website. But nonetheless, those are very important to understand and internalize moving to Agile. Because many of them, again, are a departure from the norms that existed before. They were clearly done for smaller teams, because I guess in the .com times, the teams were small, the turnaround was fast. And so delivering working software early, as opposed to a year or 2 years after specifications, was of great importance. Some of the key principles that I would like to call out from here are, remember that there are always people underneath putting principles to action through practices and using tools, that there is emphasis on self-organization and individuals and trust for them. This is also very different from the hierarchical nature of larger teams. And so, if anything, the transition to Agile has to address training of the individuals and the perception of what is about to happen. Because the work that, or how the work happens and the interactions of the team, etc., are very different from some of the things they may be used to. And the other very important point that I see here, which kind of relates to how I would like to see software development, is what in physics is called the principle of least action, which is not doing things that you don't have to. If you go by requirements, sort of requirements-driven development, then there really isn't any principle of least action, because it really doesn't matter how much code you write. But with Agile, since, well, you need to write unit tests for that, and there's effort, it kind of gets equalized to the optimal level. So that basically dealt with underlying principles and some of the practices of Agile. One of the reasons Agile enjoyed as much adoption is that it professed a readily available improvement in quality. And so to analyze how that status relates to the picture of the past and what of the quality practices we may reuse in Agile transitions, we could look at how software quality was thought of before Agile. And while there aren't too many proven quality-focused methodologies in the past, a number stand out, and there are quite extensive research numbers to back them up. So inspections, and they date back to the 80s, also known as code reviews, as was analyzed, are one of the most efficient mechanisms for improving software. Build and test automation, while not necessarily present in many software teams in the 90s, was certainly an attribute of a quality team. Use cases, and that dates back to, I think, the early 90s with Ivar Jakobsen's methodology, focus on quality because they emphasize not the behavior of the system, but rather usage of the system by the user. And certainly there was a lot of activity around root cause analysis and continuous improvement with the Software Quality Institute and the Deming prizes and the whole flashback to practices that were adopted in Japan. As far as the efficiency of these practices, one revelation for me when I first came across work of Capers Jones, and for those who haven't seen that name, he is a software statistician, basically. He devoted his career to analyzing the economics and quality of software, and he's been doing that for decades, published a number of books, and I think the great value of his work is that first he decomposed the notion of quality into defects and methods how to weed them out of a system, and he collected an enormous amount of data and still continues to do that as far as what's more efficient and when to apply which methods. So the two of the key concepts that I learned from his work were that there isn't one single technique that leads you to quality software. As a matter of fact, if any of these brilliant techniques by themselves is used in isolation, they don't necessarily give you a particularly good result. And a combination has the multiplicative effect to get to a fairly high level of quality, depending on the rigor with which these are used and the variety that's actually applied to the system. And what's interesting here is that a very large number of defects in the software system is attributed to wrong requirements, wrong designs. So the activities much preceding writing the first line of code. And of course, the software development quality practices have largely focused on, well, code review and writing tests, etc. That was certainly a good thing, but that didn't get the teams to where they wanted to be. So if you take these approaches to improving software quality, and you take the minimum effectiveness, which is on the left, you end up with a relatively poor software project with sort of a quarter of defects still remaining in the software. Whereas if all of these techniques are applied and they're highly efficient, you get pretty much defect-free software, which ends up very expensive just because doing all these things properly takes a lot of time and effort. What is interesting in this breakdown is that Agile and many of the methodologies folded in Agile naturally address many or all of these techniques in the context of software development. So some of the other data that was collected by Capers-Jones, and he tabulated data for different projects done using waterfall, iterative development, Agile, rational unified process, on and on and on. Agile Scrum on average has 40%, at least 40% better quality than waterfall. Right, so that's across a large variety of projects, large scope. Is that a good thing? Absolutely, right? Because it gives us the reason to move to that methodology. Even though the measured data for rational unified process, personal software process, and team software process, which is the child of the Software Management Institute, the same organization that produced the infamous CMMI standards, is likely to be fairly resource intensive, but it's based on very good fundamental principles. So these methodologies are better, but they're not necessarily any more flexible. If we look at practices, many of those that were mentioned earlier through the prism of Agile, Agile certainly introduced a number that were radically new. And if we think to what techniques they embody from the Capers-Jones list, that actually is very instructive to understand what actually is happening. So pair programming. It probably is a combination of a design review and a code review done at once. So no wonder that it was considered to be key to productivity and quality and XP. And that is kind of a way to do these reviews in real time. So I marked kind of the relationship of that to the code review later in the retained group. So I essentially tried to split these practices into what is radically new, what's been used before but got modified by Agile, and what's remained pretty much, or what can remain pretty much without change. Pair programming, daily stand-up as means of creating team cohesion, continuous coordination, and sort of iterative planning is definitely new, and it does bring very notable benefits in terms of team alignment and focus. Well, stickies on the whiteboard. I'm not sure whether it's a good thing or a bad thing, right? It's certainly amusing, but a number of vendors came up with software emulators for these stickies. So while the concept has remained, the implementation is a lot more scalable. Because certainly, as somebody pointed out, traceability to user stories that are stickies on the whiteboard is tentative at best. Whereas with software packages that capture these requirements, they actually automated. And time boxing versus fixed scope. If you imagine a large waterfall project, it may have been time boxed, but it definitely had fixed scope. What happened with its time boxing? Well, time boxing got blown, right? I think 80% or more of the waterfall projects were statistically linked. Whereas Agile projects explicitly enforce strict boundaries on time, which becomes very important in planning versus fixed scope that can be adjusted based on customer preferences. So now we get to something that we can actually carry forward. User stories, continuous integration, and test-driven development. So there are certainly precedents, whereas there aren't too many in old-style programming for the new practices. User stories, if there was any requirements-based development, then transitioning that to user stories is not that difficult. Use cases are a lot closer in concept, even though not necessarily close in notation, because there were various UML-rooted diagrams that were used for use cases back in the day, whereas user stories is basically English, as you know. Continuous integration is, well, to me, it's essentially an automated build that's run a lot of times during the day. The key, of course, is the trigger. For automated builds, the trigger is at 6 o'clock, whereas for continuous integration, it is somebody checked on the code. But if you have infrastructure for automated builds, turning that into continuous integration is basically a trigger or a script written around your source control system. And test-driven development at unit test level, which is kind of one of the birthmarks of Agile, either if there is a culture of test-driven development or even substantial regression testing, or if there is just a culture of creating unit tests, it's pretty easy to marry them to get to high level efficiency. And the two practices that are largely retained are code review and regression testing. Curiously, if you think about what happens in Agile, whether you do Scrum, XP, or Kanban, unless, of course, you do pair programming and do instant code review, the need for code review is still there. There can be a lot better implementation or automation of that, but the fact of the matter is that it still needs to happen. Same applies to regression testing, where whether they be unit tests, component tests, system tests, UI tests, etc., running tests to check that the system is still there and breathing is pretty much the same as it was before. That, curiously, brings us, let's see, maybe I should skip that. With peer code reviews, which is a pretty old approach, a lot of studies done on the efficiency found some curious facts that are largely addressed in Agile. So the old style code review was formal inspections with assigned roles, the moderator, the recorder, the reviewer team, etc. Were done through meetings. They were done on large chunks of code, etc. But on the flip side, while formal inspections and explicit meetings weren't necessarily sufficient, the large number of reviewers was also determined to be relatively unproductive. And so with Agile, which frequently happens, it's kind of over-the-shoulder review, you address most of these, but at the same time, if you do it informally, then lack of follow-up, unless you sort of fix things immediately, and inconsistent approach, sometimes the code gets reviewed, sometimes the code doesn't get reviewed, may hurt the team. So when code review enters the Agile world, the time is compressed because we know that Scrum is small, well, it's a week or two. So there's not a whole lot of time to accumulate the pile of reviews. The check-ins happen very fast, and there needs to be a decision whether to do a code review before check-in or post-check-in. Peer programming solves it in real time, but doesn't leave any records. With all of that fluid environment, tools are a big help. With the emphasis on automation in Agile in general, using tools for code review makes a lot of sense. There are some good open source tools. Smart Bear has one, which is highly scalable. And it sort of doesn't really matter whether you use Agile approach or not. But some level of automation for code review with Agile is, in my view, very essential. If we go to testing, that's the other part that kind of we consider to be unchanged from the past. There is a bit of confusion as far as what to do. And I actually witnessed that firsthand with one of the teams that transitioned, or is sort of transitioning still, to Scrum. And what happened was we changed, sort of broke one of the principles, which is kind of instructive, that we didn't make it one team. We have a development group. Part of that development group runs in Scrum. Part of that development group does much longer projects. They share a QA team. So from the past, the QA team is used to software is developed. Well, we all know what happens, right? They are given the software, and though they sit in the same building, they interact very closely with development. They have a relatively long period of time before the release that they do the testing. And our first Scrums that we did had a problem that we just didn't have enough time to do testing. They didn't necessarily know what to test because they weren't plugged in at that point into planning of Scrum. They couldn't figure out when to test because they were used to testing the final version of software, and the final version of Scrum software comes, well, 1 or 2 days before the end. There's not enough time to do everything that needs to be done. And another problem with testing is that done is not necessarily the same as with the final release when you're doing Scrum. And further, it may actually be changing. So what we dealt with is kind of this picture, where we had one big waterfall to begin with, and then it got broken into a few smaller waterfalls that were scrums, but within each we still had some of the same problems. And this basically describes what we've attempted to put in practice, which, having read all the references and many articles, what I put here, I think it's a pretty general approach that can work. The first thing, of course, was to make it a one team. Right? So we brought the testers into Scrum planning right up front. There were a lot of automated tests for the product that we already had. We just transitioned how we were developing new features. And so those we still kept running on a nightly basis. We didn't transition to continuous integration. One of the best things that can happen is enlist your QA group into test-driven development. There's a lot of testing that's done on our products that's based on UI, not necessarily unit level. And with that, there's obviously some threshold of, well, since I don't have access to code, how am I going to write the tests? But reviewing user stories and doing planning goes a long way to being effective with testing when the software, or the first workable version of software within Scrum appears. And while there is some ladder using keyword testing, if folks are familiar with that, where you define tests through something close to English language, and then the tool implements those tests when it finds the right elements in the GUI that's delivered, and our test complete does that. So these two steps certainly get them a lot more effective. And this also addresses one of the, I think, misunderstood elements of requirements review in Agile, because they, well, I'm a product owner. I write user stories. I don't have a sense of anyone actually reviewing them, which is a little bit of a problem, because if I misunderstand something, then we all get into trouble. So getting the testers, who basically otherwise would be sitting twiddling their thumbs at the beginning of Scrum, review the user stories for completeness, possible problems, mapping to the general design of the tool is very useful. Planning with smaller testable tasks ended up being one of the significant changes. So as opposed to having a week's worth of work that's not given to testers, having 1 or 2 day chunks made their life a lot easier. Sometimes there actually can be a compromise. There are approaches to Scrum when the team develops functionality X in Scrum 1, and then testers test that in the subsequent Scrum. I've seen that myself, not in our company. Obviously, the downside of that is if you define your delivery at the end of Scrum as something that's usable by the user, obviously if it's not tested, that's not quite usable. So that's not really a good thing, but you can have, as we know, writing automated tests is an adventure in itself, and it generally takes more time to write automated tests than run tests once. What happens, however, in the cycle is that what the testers do first, they do a manual test to make sure that things are kind of glued together correctly. And then based on that result, if that is positive, they start developing automated tests. So while you can accomplish a very high level of testing for the features in the current Scrum, there may be some backlog of creating automated tests that your testers can address, sort of to keep themselves entertained. Running a lot of tests in parallel seems to be very important, because, well, we know the concept of 10-minute build originally in XP. I am not aware of any circumstances when that practically happened, because, for example, our entire build and test takes about 16 hours. To do it in the continuous, for one of the products, to do it in a continuous fashion, obviously you need to chop a lot of tests and do just the smoke tests to make it fast. We have customers who do continuous deployment using kind of the same methodology, same level of testing. So they may be releasing several times a day. So in order to squish the volume of tests into reasonable time, either more hardware or provisioning a lot of cloud machines for that is absolutely necessary. We're going the same route. We actually realize that it's no longer practical to have that long cycle. But that's certainly an element of cost to make the team productive. As a matter of fact, one of the factors that was brought to management in the budgeting process was that we could no longer be as quick as we were before. So if that helps anyone, please use that tech. So what do we have after about 10 years? I think there's a lot of good that happened. We have empowered teams. That was, in my experience, one of the big changes that I've seen with the teams I worked with, whether they were customers that we were providing tools and solutions to, or our own. And in a sense, it was a little bit of a shock the first time I walked into it, because I was working with the product owner, and I was used to a bit more structured interaction with the development team. And he said, well, I build my backlog of requirements, give it to the development team. I don't have any control over how many they do, they just tell me. That was a little bit unusual, but that indicates that, well, there is certainly trust, and there is empowerment in the teams that do the work. There is a lot more accessible knowledge on how to make software better. And I think there's a lot of credit that goes to the very birth of Agile, because not only was it to make software faster, but it was to make software better. And just the variety of sources on how to do things so that there are fewer bugs is enormous. As a result, the quality of software is generally higher, right? So the numbers that I cited, 40% more improvement in quality with Agile is pretty darn good, right? If there's as much fewer satisfied customers, this is certainly a better picture for the industry, where I think it was, what, 2001, 2002, that NIST estimated $68 billion was spent on fixing bugs. And there's certainly faster delivery and experimentation, which plays well for both us as software providers and users. There's still somewhat anxious business side when people, the teams can't really say what the roadmap for next year is, because we don't know. Right? We know what we're going to deliver in a month. And there's certainly lots of consultants that help the team make that jump to the revolutionary XP or Agile. So what are some of the summaries? My conclusion that Agile is revolutionary in the mindset. So when we contemplate moving from something we used to do before that wasn't to Agile, the biggest change that happens is in the mind of the people who work in the organization. So this is certainly the primary factor that we need to account for. Pretty much all of Agile principles are important for quality. That's a good thing, but that's also that may be used to justify the investment. with many of the practices, a lot of infrastructure can be used. We talked about the automated builds, we talked about code review if it's already there, regression testing, and some forms of requirements and user story analysis. But most of the thinking may need to be left at the door, right? As we talk about unified teams, as we talk about testers doing things very different from what they're used to. Adoption in the test groups is generally more challenging because, oddly enough, there is less change. With development, there's a whole boatload of things that they're excited about. With testers, they're kind of at the tail end, right? They're led by the development team. They're forced to adjust to the practice of the development teams, and they don't take initiative too often to actually step up to the plate and contribute to the process. So with that, let's talk about some of your experiences. Let's ask questions. So I'm happy to answer. Maybe we can ask them to one another. Please.
These days, prevalent, like between Agile and Waterfall, and I guess to the completeness, neither. Is there I mean, Waterfall either in terms of the Niagara or in terms of a couple of large cascades, like your slides. Just as a figure of speech, how much is there that is Waterfall and how much is more responsive, Agile, and the like? And as, I know often, last time I worked with a company, it was practically Waterfall, even though they said something else. But have you seen it? What is it?
So the question from the audience was, what do we know about the distribution of Agile projects versus Waterfall versus somewhere in between that we don't even know what it is? The only statistics I know is that more than half of the new projects now are started as Agile. It's kind of hard to tell because some people may say it's Agile, but they use some of the sequential practices, right? Because Waterfall, in other words, is kind of a relay, right? You pass the baton to one another, where Scrum is more of a parallel motion, right? And what determines the finish is when everybody gets to the finish, as opposed to the last person in line. Now, whether you sort of split, if you're running a team of 4, right? If you split that into 2 teams of 2, right? And they run sequentially within each other, but there's still some parallelism. I think it's very situational. Part of this gray area, or part of the existence of this gray area, is probably due to some of the matters we talked about today, which is it's pretty hard to jump from what you used to be to Agile. I guess Kanban is one way of doing that, although it doesn't necessarily prescribe what you do first, right? You sort of do one thing and then you see what happens. So how we classify that approach, whether it's Agile or not, I guess it's open to interpretation.
That was easy. There was that one part where you were talking about writing the automated tests in the next sprint. Mm-hmm. That just flies in the face of so much that I've heard about. The justification of Agile's actually paying back for itself is that bugs that you fix sooner are cheaper to fix. Mm-hmm. And then, also the definition of done. How do you call the job done if you're like, okay, we've done in this sprint, now we're going to go write the unit test for it. It just doesn't make any sense for me.
Right.
Quality.
If you talk about unit tests, and if you have that methodology, it does not. But writing unit tests is generally not as expensive. The overhead, I believe, in the study that was referenced, was around 25%.
No, I'm
Right.
not talking about the
But-
cost of writing the unit test.
Yep.
I'm talking about the added cost of fixing the bug later when the developers have already moved on to some
Right, so
other
let's,
thing.
let me clarify that thought, because I was reasonably careful when I proposed that, because where do the bugs come from? The bugs may come from developers testing their code, or developers may come from testers testing the end result. You need to do at least manual testing within a single scrum. There is a manual test step before you write automated tests at a system level. Right, so you can't really do a manual unit test in a sense, right? Doing a manual unit test will be running your code in a debugger, which is, so it's pretty old. But in terms of having to run a system manually before you automate a large-scale test, it's pretty much a standard practice, because you get to the end result faster. And why do you automate to begin with? Well, because you don't want to do something manual more than once, but you need to do it once at least. So that's my response. Great question, though.
So have you seen any metrics around acceptance test-driven development and the return on investment on those?
Acceptance, I'm afraid not. Is there anything in particular you're interested in there?
Yes, so, particularly the value of writing tests at the story level and not at the task level, and what that the acceptance. So ATDD as opposed to just test-driven development results.
I see. No, but that is an interesting question, because I guess TDD in the traditional application is very small tests, a great number of very small tests written by developers, right? They are indeed at a task level, and what the acceptance tests would be is sort of system tests, maybe at the UI level, right? The one aspect here is that it's much more difficult to write them without a functional system. As I mentioned, there are some ways around it. Either you plan them, right, so you shorten the path, or you use keyword-driven testing approach, which also almost amounts to writing the test in English, but then the tool is smart enough to recognize what you wrote, because it's not just plain English. But as far as the efficiency of that, I venture to say it's possible. I'd look for it, as a matter of fact, because it's that is a lot more relevant to our line of business at SmartBear. So that's a great question for us to ponder.
I could add to that I believe it was last week, somebody posted an article to the Scrum Practitioners Group on LinkedIn on that subject. So if you go back, I don't know if you're in that group or not, but I think just last week somebody posted an article on that there.
When you were trying to implement Agile in an environment where people have not practiced it before, did you encounter much resistance from developers who felt that with an Agile method they didn't really know where they were going, and they were having to write parts of code that they would have to throw away when they understood more of the project? That it's by getting user stories in small increments, or well, in sprints, without understanding the full scope of what was happening, was there resistance to doing things that they were afraid would be discarded?
Not much. I took, I applied focused effort on my part to minimize potential waste when we were negotiating sprints. Within the sprint, there wasn't actually a lot of code wasted. So we were trying to evolve the architecture or functionality in a way that was relatively unlikely that something will get wasted. But that wasn't a significant problem conceptually. The significant problem was ownership. The click happened when that, so first phase of putting Scrum in place was when I tried to push Scrum on them. So we created some organization, we used smaller delivery times, smaller scopes, and so forth, because, for example, the difference was that, well, it's 3-week delivery time versus 6 months delivery time before on a single project. But they were questioning a lot of things until the whole team went to training. And then they basically picked it up on themselves, and they're self-enforcing. So that goes back to the notion of self-organizing teams and empowerment. Because as a product owner, well, I'd like to consider myself being part of the team, but really I'm not. Right, I'm sitting right at the edge of it. And Agile, it seems, cannot be forced on people from within the company. A group needs to adopt that internally to actually be productive and proactive in playing by the rules.
I guess I'd appreciate your elaborating a little bit on what you did in the architecture to avoid discarding code between sprints. As you said, that wasn't a problem because of the way you arranged things, but tell me how you arranged things.
I think it was more empirical. It was selecting user stories that, in my opinion, would not cause a lot of code leakage, but something that you throw away. Not a whole lot of kind of rigorous thought that I can share. It was basically a judgment. But I think that if you adopt that thinking, then the probability of it happening is a lot less. Because you can essentially sequence things by value only, right? Or you can factor in the value that you back to the system.
In looking at the things that improved your quality or list of things, it tended to be either at least two people looking at reviewing the same spec code, etc., or testing. I'm toying with the idea that the key thing for improving quality is having these two people with different views approaching the same problem. That question is, if you have the developer developing his own tests, does that have the same quality improvement as having another person writing the test for the developer at the same time?
Actually, there is statistic that shows self is a lot less efficient in finding bugs in his own code, right? It's actually been measurable. So I am therefore, while I generally support the notion of unit tests, of test-driven development when you're writing code, I view it much more as a matter of focus as opposed to a matter of rigor. Because even without writing unit tests before writing code, one of the basics is, well, have you read the requirement that you're writing code for? And I've seen many cases when people started writing code without understanding what that's about. So if they were writing unit tests to their understanding of that requirement, that wouldn't have helped. Right? It would probably write robust code, but they would do the wrong thing. So that's why kind of third-party QA, and in terms of third-party QA, I mean a different group, right? In terms of outsourced QA, it's kind of a sore topic that I don't want to go to. But the presence of testers who don't touch the code and validate the system, either in small chunks or large chunks, is extremely important.
I was wondering between unit testing and integration testing, it suggests that a key part of the Agile setup is what items get put on the backlog list and how are they related. And in particular, how do you make sure that they're as little coupled as possible? Because if you pick the backlog items wrong and they're strongly coupled, each item may be done, but when you integrate, you run into all sorts of problems because one affects the other. So how do you make sure there's a minimum of coupling among the backlog items?
I can't claim I've tackled that problem. I understand that was about. We haven't seen, well, at least I can speak for the groups I'm working with. I haven't seen that to be that serious in effect. But we have thousands of test cases that we run. So in terms of coupling effects to the old code, that's reasonably well covered. In terms of new features, I don't, well, other than judgment at this point, right? So you could pick features that relate to different areas of software, right? We did, however, have a sequential problem when we were trying to get new data acquisition implemented and then build a report on top of that new data acquisition. I didn't see that mess up too many things. So they worked it out. I wasn't part of working it out.
I have one particular Scrum team, and one of the things as they're getting their Scrum legs is trying to implement unit testing and code reviews, and there is some challenges because of the lack of enough testers on the team. There's only one full-time tester, so the team itself tends to test each other's code, so developers chip in. But we always follow up in the next sprint or the sprint after with the unit tests, and the question comes up with the code review and whether it's a good idea to do the code review before or after the unit test, because you can see a benefit to either way. The code reviews may pick out areas to unit test that you hadn't thought about. So any opinion on that?
Let me redirect that to the audience. Has anyone dealt with that kind of situation before?
But we wouldn't consider the work done if it wasn't tested.
We do.
I mean, that's part of it, and it's automated as well.
We do manual tests, you do.
Yeah, automated testing as much as we can with the current tools we have, but
I think this was the last question.
Yeah, part of the point of the code review is not just, is your code doing what you think it's supposed to be doing, but were you thinking it's supposed to be doing what it should be doing? So I would say having a code review before would be much more valuable to save work. I think that's all the time we have for questions.
Thank you very much.
Good. Thank you.